Good to see all of you. Rise and shine, early morning here. Hope you found some coffee. My name is Markku. I'm a solutions architect at Google Cloud, and I focus on IoT. And that's exactly what I would like to show you this morning. I'd like to show you how to build IoT solutions using Sigfox radio network for IoT devices and Google Cloud. So let's get started. First, I'd like to talk to you about LPWAN. What is LPWAN, I hear you say? Well, it's low power, wide area networks. With IoT, it's super important. Okay, you might have an IoT device in your home, but many IoT devices are actually out there. They are maybe measuring air quality in a field or up in a mountain somewhere, maybe measuring some floodgates, water levels in a canal or whatever. So they are somewhere. You may have thousands of them. We have customers who have millions of IoT devices, so there's quite a bit of scale. So you want your devices to be kind of autonomous and self-managing and low maintenance. You don't want to have to go there all the time to charge them and check them. They need to just survive on their own. So low power means that you can run your devices with battery power. So you can easily, with these solutions that I'll show you today, build solutions where the device can run from a single battery for months or even years. And wide area network means that if your device is up in a mountain or in a field, it can still connect where? To the internet. So one way to do that is with our technology partner Sigfox. So Sigfox is providing a radio network specifically for IoT. They call it 0G, not 4G, 5G. They go the other way, 0G. It's extremely low bandwidth, but it's really nice for IoT. I'll show you. And when you build IoT solutions, you unfortunately also need to consider the costs. So there's a lot of cost elements. There's the hardware cost. So if you buy or specify a very simple, very constrained microcontroller, you can squeeze the hardware cost down. That's good. Microcontrollers are also reliable because they don't really have an operating system. They just get some power and they execute a binary that does stuff like read the air quality sensor reading and send it out. So that's it. That's the hardware cost. With Sigfox, you need a radio module. That would be a couple of dollars. And then the connectivity is something like this, from $15 per device per year down to just $1 per device per year. So that's nice if you have thousands or millions of devices. So Sigfox provide the radio network. They build the base stations. They connect them. So they provide the coverage. They currently have about 60 countries covered, and 21 of those countries have nationwide coverage. Now, what is LPWAN here? First of all, with Sigfox and LPWAN networks, the payload is extremely small. That's why it's 0G. It's not 5G. The maximum data or sensor telemetry usually that you can send with Sigfox devices is 12 bytes uplink. So from device up 12 bytes, so 96 bits. You have 96 bits to play with, and now you're like, this cannot be, it's 2019, what are you talking about, 12 bytes? Crazy. It's good. You can squeeze a lot of information in those 12 bytes. 0 bytes can be actionable information. If you just send a message with no payload, it's still a message, it has metadata. That can be a heartbeat. I'm still here, the air quality monitor, I'm still here. 1 bit can transmit 0 or 1, true or false. Like, how is the water level in this drainage canal? Is it too low? Is it too high? No, 0. With 6 bytes, you can transmit GPS coordinates, and you still have 6 bytes left for things like sensor readings, multiple sensor readings. So that's uplink, 12 bytes up. And you can transmit about 6 messages per hour with Sigfox network. So that's about 140 messages per day. Now, usually, these sensor readings are sent like every hour, etc. Downlink is then from the network to the device. So that could be a command that you send to the device to do something, maybe based on analytics, or maybe you want to update the device configuration. Now with Sigfox, you cannot push messages to the devices. They are not listening because they are sleeping so that they can conserve power. the radio is off. So how does it work? With Sigfox, the device can set a flag, so you in your code on the device can set a flag that says, I want to have a downlink response. So when it's sending something, there's a flag, and then the network can send back a downlink message, which is 8 bytes. So that would be your device configuration and maybe some commands. Now, in order for these devices to have highly successful transmission of data, Sigfox is using narrowband. It's extremely narrowband transmission, 192 kilohertz radio burst. No protocol. There is no protocol. So in order to save power on the devices, there is no handshake. There is no connection to the network and handshake, hi, I'm here, hello. No, they just send. They literally just encode the data and modulate it with radio and send a radio burst. They actually send or transmit 3 radio bursts, the same message 3 times. They do channel hopping. They send the same message 3 times consecutively in 3 different channels. This is increasing the likelihood of the network hearing and receiving the message. And then the rest of the time, the device should be sleeping, especially if it's battery or maybe solar powered. So 99-point-something% of the time, your device can be in deep sleep. So nowadays, there's a lot of microcontrollers, MCUs, that you can literally put to a deep sleep mode. Now, if there's a Sigfox radio there, while the device is transmitting, it's consuming some milliwatts of power.
Thank you for joining this session.
You're welcome. And then, when the device has finished transmitting, you should put it to deep sleep. And then maybe it sleeps 10 minutes, maybe it sleeps an hour, maybe it sleeps a day. When the MCU, depending on the microcontroller, is sleeping, you can go down to nanoamps of current. So the device can actually consume less power than the battery's natural self-drainage. You know, batteries lose some power over time, so you need to choose some battery types that have less, that keep the power longer without any loss of power over time. Anyway, most of the time the devices are sleeping. And then the wide area network part of this is the link budget. With radio connections, radio connectivity, the link budget means like, if you transmit a signal from your device, how easily can the network actually hear this signal? And Sigfox is really good at that. Depending on the different countries and frequencies, if you look at the uplink FCC, so that's here in the US, the devices can transmit at 22 decibels. That's a radio power. And the network sensitivity for receiving is minus 134 decibels. So actually, the Sigfox radio network can hear the message 134 decibels lower than the transmission power. So very, very weak signal. So in practice, it means that if a Sigfox device is transmitting, in urban areas where there's buildings and stuff like that, you have a few miles of distance to the base stations, but in rural areas, maybe some fields, etc., you can have dozens of miles, dozens of kilometers range. So that's good. So let's get to the integration now. So Sigfox is one option for you to have connectivity, especially for remote devices somewhere. And Google Cloud can then help with the data. So the main point is this. Your devices emit these sensor readings, maybe air quality, whatever. Sigfox antennas pick up these messages. The Sigfox platform can optionally then forward the data, forward the messages to a backend system. And in this case, we can use Google Cloud and our data services in GCP to receive, analyze, store, and have actionable insights from the data, maybe even machine learning. So to help with this, in January, we published the integration. The QR code there and the URL on the top bring you to that tutorial. So it's fully open source. The tutorial gives you the step-by-step guidance how to actually integrate your Sigfox account and your Google Cloud account. And everything is open source, and all the code is in GitHub. It works like this. On your left, you have the Sigfox devices. When they transmit messages with your sensor readings, they go to the Sigfox system, Sigfox platform. And then you can configure a so-called callback or multiple callbacks that if you get data from your devices, or if there's something else to notify the backend system, Sigfox can push the messages to a backend system. And that's what we have implemented with the integration in Google Cloud. And we are using cloud functions for that, because with Sigfox, first of all, you have very small data, maximum 12 bytes per device. And at maximum, a single device can transmit every 10 minutes. So most of the time, there's very little traffic, unless you have millions of devices. So cloud functions are really handy because you can scale them down. They appear, your compute system appears when there's a message. So the payload will trigger the compute, so it's event-driven computing. And it's serverless, meaning that you don't have any servers running, and you don't need to manage any servers or even any containers. So the cloud function will receive the data from Sigfox. There's, of course, authentication and encryption for the link there. Then the cloud function will check that the message looks okay, it's conforming to the Sigfox standards. So what is coming to the cloud function is the payload from your device, and then metadata around that, like what is the device type, maybe what is the Sigfox operator, like US, etc. So there's the metadata, and then the payload. And remember, the payload is binary encoded, maximum 12 bytes. Once the cloud function receives this payload and metadata, it will drop them in Cloud PubSub. Cloud PubSub is our global message queue. So it's a really handy place for you to keep your data reliably, up to 7 days, and then process the data from this message queue with your data processing system. So in effect, you get a real-time streaming data of payload into Cloud PubSub. And if the devices are requesting a configuration update, a downlink message, then the cloud function will detect this flag that the device is saying, hey, I want to have a downlink message. And we use Cloud Data Store as a really simple, easy, handy database service to store the device configurations. So you will create the device configurations. We check the device ID, device type ID. If they are requesting a downlink, we get the payload, the configuration from data store, and the cloud function sends it back to the device through the Sigfox network. Also, if the Sigfox network is sending any service messages, we have a second cloud function receiving those and just logging everything in Stackdriver, which is the logging system in Google Cloud. Now, that is the integration, and the integration is device independent, it's solution independent. It works with any solution with Sigfox because it just takes the payload as is and drops it in PubSub. But every IoT solution will be different based on your devices and use cases. So after PubSub, it's good to have a device-specific and use case-specific backend system. For example, you can use another cloud function then to look at this payload in PubSub, or data flow. With Cloud Data Flow, you can create Apache Beam DAGs, directed acyclic graphs of data processing steps. You can enrich data, you can branch it, whatever. So data flow is great for that. And after pre-processing the data, you want to store the data in a data store. We have many handy services for that, like Cloud Bigtable, extremely fast and scalable key value store. Very good for time series data. And a lot of IoT data is time series. But BigQuery definitely is probably the most likely data store that many people use. It's becoming a data lake, if you will. So with BigQuery, you can store your data there in real time. So the system can write the data in BigQuery in real time. Then your data warehouse is up to date in real time. You can run machine learning inside BigQuery on your data without moving it anywhere. And of course, you can have analytics, dashboards, etc. connected to your BigQuery data warehouse. And you can use CloudML and other machine learning services then to do things like maybe predictive maintenance, looking at trending of your sensor values. I talked through the functional requirements on the left already, but when I created this integration, we set some non-functional requirements as well. So we wanted this to be serverless, so you don't have to worry about running servers or managing them, event-driven and stateless, and scale out, of course, if there's a lot of traffic. But importantly, also scale in, even to 0. So if there's no messages coming from your Sigfox devices, the system will scale in and kind of hibernate, and it's woken by the messages and That means that's what event-driven architecture means. The messages will wake up the system, and it will process your messages. And of course, everything is customizable and open source. Now with that, let's actually see the demo. So, live demos. So first, we switch to my Sigfox backend. So when you create a Sigfox account, you get access to the backend system. And then for your devices, or device types, which are groups of devices, you can optionally configure these callbacks. So these callbacks are the instructions in the Sigfox network side. If your devices are sending data, do something, send it somewhere else to a backend system. So we can see here that in my Sigfox backend, we have some callbacks already configured. And if you can see over there, the callbacks are actually implemented by cloudfunctions.net, so Google Cloud Functions. We have different callbacks here for data, for service messages, etc. Now, as part of the integration, of course, you can use the user interface, but I also made a command line tool that uses the Sigfox API. Because to configure the callbacks, it can be a bit tedious. There's a lot of parameters, etc. So we are humans. We make human mistakes, human errors. So I wanted to automate it. And also, then maybe you can build a CI/CD pipeline that uses these command line tools as part of your automation. So to use this Sigfox API command line tool that's part of the integration in GitHub, first we can execute callbacks list. And there's a configuration file which then has your credentials and your API keys and points to your system in Sigfox. On the bottom, you can see that now for this Sigfox device type, which is the one for the demos, we have 5 callbacks configured. That's right, we have 5 of them here. But if we use now the same API and we execute callbacks delete all, oh dear, gone. So now the API client said we deleted the 5 callbacks. If we refresh the screen, they're gone. That's it. And let's put them back. So simply, I just execute create, if I can type it. There is a configuration file. There's a JSON file which contains the callback configuration. So mine are examples. And if you need to modify them or add them, you can simply modify this JSON config file and add or modify more callbacks. So this script will read that JSON file. And by default, it will create these 5 callbacks that point to Google Cloud Functions. There we go. Now it's back. So let's actually now go back to the slides and start using this system. Let me show you really quickly a piece of the code. So this is the Sigfox API command line tool that we just used. Sigfox has a Swagger configuration file for the API version 2, and we generated a Python client in this case. It's in Python. And how it works is very simple. I've got the JSON file that contains the configuration, the desired configuration for the Sigfox callbacks that point to Cloud Functions in this case. And then the script will just run through all of those in the template. In this case, it does 5 loops and calls the API instance, create callback function for each of those callback configurations. So very simply, it will loop through and automatically create the integration. So that's handy. Now, let's actually use it. So let's have a live demo now. I've got here on stage my Sensit Discovery version 3 device. It's a microcontroller that's battery powered. I charge it every couple of months, if I remember, so the battery lasts a long time. It's an off-the-shelf development kit that's handy for getting started with Sigfox and IoT and Google Cloud. It's got a lot of sensors, ambient sensors, temperature, humidity. There's a magnetic sensor. There's an accelerometer, light sensor, etc. And of course, a Sigfox radio. So let's now see what we have here. So we have the integration, which is the middle gray part. You saw that, or part of that. And on the right side, we have a device-specific backend. So when this device is sending data, it has a defined payload. It's got the sensors, and depending on the mode of the device, it actually changes the payload. So the payload is dynamic. But as part of the payload, the device is transmitting a value. What is my mode? Mode 1 is temperature and humidity. So then the rest of the payload, actually, we know that it contains temperature and humidity information. So that's a device-specific payload that leverages those 12 bytes, actually only 4 bytes in this case. So to handle the device-specific data, on your right, I've created a device-specific backend. And we have also published this as an open source tutorial. And let's take a look at that now. So let's use this integration with this Sigfox Sensit device. So let me show you the device. Here it is. On the table, it's quite small. So it's a battery-powered MCU with some sensors built in, small LiPo battery in there, and a button. And then let's go back to my laptop before we send any data. So remember, we've got the callbacks here. So if any data comes from my devices, these callbacks will be activated, and Sigfox will send the data to Google Cloud, specifically here. So now we are in Google Cloud, and this is the receiving side of the data. This is the integration in GCP. We've got the 2 callbacks here. Callback data, which is receiving the data payloads, and the optional callback service, which is receiving service messages and logging those in Stackdriver. And we have the logs here. So this is the callback data, Stackdriver logging. And the device itself is here. So this is this particular device. And now, if I switch here and I double-click this button here, we should see a blink, blink, blink here. There, it's now transmitting those 3 bursts, 3 radio bursts. And we go back here. You can see green, callback OK. So the Sigfox callback was activated, and the arrow turned green, meaning that Google Cloud replied with a positive acknowledgement, "Thank you, I received the message." So Sigfox received the radio transmission and forwarded the message to Google Cloud. And the actual data is here. You can see that it's hexadecimal, signifying that it's binary encoded. So 8 characters in hexadecimal are 4 bytes. So it's actually 4 bytes of binary encoded data. I will copy it to my clipboard, and I can show you later how to decode it. So let's go back now to Google Cloud. Look at the callback data function, and it should have been triggered. Here we go. So this function was triggered by the message just now. And if we go to the logging of this function and we refresh the logging, here we can see in Stackdriver logging, it says, we received a Sigfox message from this device type, from this particular device ID at this time. The data is there. You can see the data is still in hexadecimal binary encoded format. That's the payload. The operator is here. And the next message says that simply we publish the message to PubSub, to a particular topic. So now we get the payload in PubSub. And then your data processing system can pick it up from this message queue in real time, maybe Cloud Functions or data flow, and do something with the data. Now, what did we actually send? Let me show you. As part of the integration, we also published a tutorial for this particular device, a tutorial that creates the device-specific backend that uses BigQuery. And we need to have a parser, because the device is sending binary payloads. Those are a little bit difficult to use. So let's decode the binary messages using the specification of the device, and then write to BigQuery a normal set of columns and values. So how do we do that? I have a cloud function, another cloud function here, this one. This cloud function knows the binary payload of this device type, Sigfox Sensit. So the PubSub BigQuery cloud function will get the messages from PubSub, which contain a binary encoded payload. It will decode them and write them to PubSub, to BigQuery. The same parser also has a command line tool, so that you can do debugging and testing and maybe developing your own binary payloads. So it's an example for that. So here we can see that we could execute Python Sensit, which is this device, parser mode decoding data, for which hexadecimal string from my clipboard, the same that the device sent. I press Enter. And now we can see that the parser is identifying from the mode what is the device mode. There's a certain 2-bit value there that specifies the device mode. In this case, it's temperature and humidity. And then the rest of the payload is decoded using that information. And we can see it down here, that the battery level is now 4.1 volts. It's 54% humidity. Mode is temperature humidity. Temperature is 20.2 centigrade, so it's pretty chilly here. And the button alert flag is true, meaning that the device sent the message because I clicked the button. The other option is sending it with a timer. OK. So now we can decode the message. That's what this cloud function does here. Pops up BigQuery. If we look at the logging of this cloud function now, what happens is that this function is triggered when the first function puts the payload in cloud PubSub. So the first function puts the payload in PubSub as is, as a hexadecimal binary string. This second function is device-specific, and it knows how to read this binary payload. So if we look at the logging of this function, we can see here that this device sent some data. OK, that's it. But the next row in Stackdriver logging for this function has already opened up the data. We can see here that in addition to just the binary payload here, we now have new values. We have battery level, we have temperature and humidity. So that the next step for this function can be this. It formulates a BigQuery row and then simply writes the data in streaming mode to BigQuery. So now the effect is that when we send data from Sigfox devices using this integration, your data warehouse, which can be, for example, BigQuery, can be real time. So here we are. We are in Cloud BigQuery. And I have a very simple SQL query here. Select star. I'm not supposed to do that. Anyway, from this table, ordered by time descending, limit 20. And let's execute that. And it's in UK time. So the last messages sent by the device are here, the same data payload. But you can see in BigQuery that we have handy information here, battery level, temperature, humidity, and all the other sensor readings, which are not sent now, but they are sent in another mode of the device, have a placeholder here in the BigQuery schema. So then you can start analyzing in real time your data warehouse for IoT data coming from, in this case, Sigfox devices. You can have real-time dashboards, and maybe even machine learning doing things like predictive maintenance, trending, other things, looking at the actual values. And everything is end-to-end real-time. Now, the device can also send configuration update requests. So for example, here, you can see that we have a lot of short messages, 4 bytes. But every once in a while, the device is sending a much longer payload string. Now, what is that? Let's put this in my clipboard. I copy that to the clipboard. Go back to the Commandline tool. And let's investigate what is actually inside this binary payload. The parser can now detect that actually this long string here contains both the data, which is the sensor readings, 4 bytes, and an optional configuration. So when this device is sending a configuration update request, it's also sending its current configuration. By the way, I'm currently using these configurations. And the parser can decode those. And what you can see here are the valid configuration parameters and values for the Sigfox Sensit device. So it's sending all these. This is the device configuration. So this is the device telling us what it's doing now. And in order for us to actually use this and easily update the configuration, we can do the following. We can use the Commandline tool, paste the received payload from the device here, and specify that we write the device configuration in an output file, temp/sensit.ini. Bam. Config file written to temp/sensit.ini. So if we now VI, if we edit this, it's actually the current configuration sent by the device but it's in human readable and human editable format. So what we could do, for example, is change the message period, which is the timing, the interval of the device transmitting data. 1 in this device's case means every hour. But if I change the value from 1 to 0, I'm asking the device to transmit every 10 minutes. So we modified that one parameter value, the first one, message period. I save it, and then I run the parser the other way around. I want to encode a new configuration from that configuration file that we just edited. Boom. So all this is open source. It's in GitHub as part of the integration. And even if you don't use this device, you can use these configuration and payload tools and parsers as a starting point for you to develop your own binary encoded small sensor readings and device configs. So that's the main point here. So the tool is giving us a new configuration hexadecimal string. That's the desired new configuration for the device. Copy it to the clipboard. And let's now go to Cloud Data Store. So Cloud Data Store is where we keep the device configurations. And if the device is requesting new configs, we can simply modify the value here. Let's write the new config here. I click Done, and I click Save. And that's it. The next time the device is saying, hey, Cloud, can you give me my new configs? The Cloud function will pick up this value and send it back to the device. So that's quite simple. Okay. Moving on. So far what we have seen is we've seen the Sigfox callback configuration. We've seen the device. We've seen the Cloud function that receives the data. We looked at the logs. We did some parsing of the binary payload. And we saw that the data lands in BigQuery. So that's good. Then you can do your analytics and data warehousing in BigQuery. And how did we actually do the parsing? Let's take a quick look at the code. I'm using Python's bitstruct module here because it's really handy that you can declare a binary payload. So remember, we have up to 12 bytes of payload, so 96 bits. And in order to use those 96 bits in the most efficient manner, you really want to minimize the number of bits and bytes that you use to convey some data. So for example, 1 byte can be 255 values, right? It's 2 to the power of whatever. So 255. That could be, for example, the speed of your car. So the speedometer reading easily fits in 1 byte. Okay, then you have 11 bytes left. Okay, battery power. Maybe I can get by with 4 bits, so half a byte. So you get the idea. You start constructing the minimum number of bits that you need to convey certain values with the desired accuracy. You can always drop the accuracy and get by with less bits to transmit the data. So here we have an example from this device where first in the top lines there, we investigate the device mode. So as part of the payload from the device, it sets a certain value, mode, indicating what is the current mode. And then the rest of the payload is dynamic based on that. So if the mode value is 1, then the device is in temperature humidity mode. So that's here. And then as part of the open source parser, we have a bit struct that specifies exactly how many bits are used for what values. And then on the bottom, we can simply call this parser to give us the human readable values or standard Python values like integer and float, etc., from this binary mess. Now, as the last thing what I'd like to show you, that was the generic data up and down with Sigfox and Google Cloud. A handy thing with Sigfox is that it can do estimated device location without any GPS or GLONASS or other satellite system. Because the Sigfox network is so-called MIMO, multiple in, multiple out, everybody's talking at the same time, they have multiple base stations. And typically around 3 base stations will receive the same message from the devices. So then the Sigfox network can reverse engineer and calculate an estimated position and location of the device. It's not as accurate as GPS, of course, But it's still nice because then your device doesn't have to have a GPS receiver, which could be more expensive than the rest of the device. The GPS receiver needs to see the satellites, hear them, and it also consumes a lot of power. Of course, you can have GPS and you can send the coordinates, but with Sigfox Atlas positioning, you can get a rough estimate of the location no matter what kind of device you have. So imagine that you are monitoring the transport of some goods, maybe some frozen items that need to stay frozen from the manufacturing all the way to the shop. So you need to verify the cold chain quality. So if you just put a sensor there in the container, physical container in this case, and occasionally send these sensor readings, you can get a real-time update when, for example, something starts to melt or temperatures going up. And then with this positioning system, you can even see where. Maybe it's on 101 going up to San Francisco or something. You get a rough estimate of the location. So let's see how we could use the same system with that Sigfox Atlas positioning, BigQuery GIS, the new functionality in BigQuery for geographical queries and Google Maps. So let's switch back. And let's take a look at BigQuery. There's something else I didn't show you earlier. So when I showed you earlier that now in BigQuery we have the data coming from the device, very nice, yes, they are here. But if we scroll right, there's more columns. Here we can see that actually, as part of the metadata coming from Sigfox, when Sigfox is forwarding the data to the backend system, it's also including the computed location, latitude and longitude, based on the Sigfox Atlas estimated location of the device, based on which space stations actually heard the message. So you start having coordinates in your BigQuery database. And what can you do with those? Well, for example, this. So BigQuery now supports GIS, so geographical queries. So we have a nice visualizer where you can start testing things. So specify your project, your GCP project, and then, for example, you query BigQuery with a standard SQL query, but you put there a specific value, geopoint. So you're telling the system that, hey, these two column values here in my data warehouse actually contain geographical position coordinates, latitude and longitude. So that's the first part in the select statement there. WKT will then contain the coordinates. And then I'm also asking or querying from BigQuery the device ID, the temperature, humidity, and battery level from the device data. And then let's see what happens when I click Run. So now we are executing that query live against BigQuery. And currently we are looking at the last 20 messages. Let me increase that to 30 messages. Let's look at the last 30 messages. Aha, you can see that I live in Singapore. So when we go back in time more, you can see that Singapore starts coming up. So basically this is now asset tracking. We are tracking my device earlier. And if I put the query back to last 20 rows in BigQuery, everything should be near here. What I actually did was I drove around this bay, and my device was transmitting at regular intervals, so we got some transmissions there. And if we zoom in here to Google I/O, you can see that all these messages were transmitted during I/O. So if I click on one of these, you can see that we have Google Maps, and we are overlaying on Google Maps map pointers, and the data in the pointer is the actual device data coming from BigQuery. So we don't have any extra tools here. All of these are native from GCP and Google tools. So we have a nice, easy maps integration with geographical data in BigQuery here. So that's very handy. Quite often, it's good to know where your IoT devices are, and you can do things like geofencing, for example. Have an action when your device enters or exits a certain radius, a certain area. So with that, I really hope that you found this useful, and I hope that you enjoyed it. A couple of useful links here. Please let me know how you think. Thank you very much.